Good evening, or good afternoon. My name is Takiwa Smith. I'm founder and executive director of Science, Engineering, and Mathematics Link Incorporated, and I want to welcome you to our virtual Teen Science Cafe. The Teen Science Cafe is a program of our community STEM program in which we host virtual and in person events to engage youth in hands on STEM activities, STEM career inspiration activities, and interactive demos to get them to teach and reinforce STEM concepts as well as expose kids to various STEM careers and do what is the essence of our work and then why we are named SEM Link to connect youth to the STEM community. Our Teen Science Cafe is a program specifically for teens because at this stage of your K through 12 experience is when you start making decisions about your future. If you're in middle school, you decide what out of school time programs you participate in on the weekends and during the summer, what extracurricular activities you will do at school, if you're going to go to a magnet school for high school, and all those different decisions that you make, you and your family, caregivers make in middle school. In high school, it allows you to do some of those same things as middle school, what extracurricular activities, what out of school time programs you can participate in. But it also allows you to think about what you'll major in college, or whether the path you want requires community college, an associate's degree, bachelor's degree, graduate or professional school. And so we feel like you can make those decisions when you get an opportunity to meet and interact with members of the STEM community. And so that's we host these teen science cafes and we host them virtually. So if you're not in Atlanta or you can't make it to our in-person events, cafes, and you're in Atlanta, you can get an opportunity to meet somebody virtually, catch them on our YouTube channel if you don't catch it live, and get an opportunity to explore various careers. And so this month's guest is an engineer, which I'm a little biased as an engineer. And I'm going to say one quick thing. Although we have an engineer, this month is chemistry week. And so we do have chemical engineers and we celebrate chemistry week. Next week is National Chemistry Week. And so I encourage you to do some fun chemistry. There's a website that has various chemistry engineer, but activities you engage in, but just learn a little more about chemistry and how it impacts your world. And this today's topic is engineering. And as I'm biased as an engineer, engineers make the world, right? Everything in our homes and our lives. An engineer has had some hand in making it, whether it's designing it, whether it's developing the process, the schemes, whether it's actually um, making the plant, working in the plant to help make it. And so we owe as society a great debt to engineers. I'm not saying that because I'm an engineer. I'm saying it because it's true, right? From our traffic lights that civil ends through our bridges, our homes, um, access to clean water, the clothes we eat, the food um, we drive, everything is impacted by an engineer. And so I want to welcome our guest, excuse me, Mr. Jabari Wilson, who is a mechanical engineer, I'm almost certain. And Mr. Jabari Wilson is a graduate student pursuing a PhD in engineering education at the University of Florida. He has experience working in project management, quality control, manufacturing, and mentoring. These experiences were gained across the construction, automotive, and research industries. He has a passion for education outreach and believes that the best work we can do is work that benefits the future of the world and those in it. So far, he has served as an AP calculus tutor, a chess tutor for middle and elementary school students, an assistant director for a rockets and robotics camp in his hometown, and is a peer advisor for incoming PhD students in the Florida Board of Education Summer Fellowships Program. So, without further ado, I'm going to turn it over to Jabari. You're a mechanical engineer, right?
Yes, ma'am.
Okay. Okay. I'm going to bring your presentation back up.
All right,
Okay.
great. So thank you for that wonderful introduction. Like Ms. Smith said, I'm Jabari Wilson, and I'm honored to be here with you all today. Um, so let's go over a little bit of an agenda on what we'll be covering. I'll go over a little bit of background about myself and how I got involved with the Air Force Research Lab. Then we'll go over some opportunities with the Air Force Research Lab and other programs connected to the government. We'll transition into the second half of our session today with a mentoring activity. So please go ahead and grab a pencil and paper or have a note on your phone ready or something like that. So when we get to that part of the presentation, we can kind of have an interactive aspect to that. And then lastly, we'll finish up with some basics about engineering and an example video of some of my favorite engineering to see in action. So here's a little bit about me. Like I said before, my name is Jabari Wilson. I'm from Huntsville, Alabama. That's a city with one of the highest concentrations of engineers per capita in the United States. I earned my bachelor's in mechanical engineering from the University of Alabama in 2019. And after that, I got a master's in mechanical engineering with a minor in electrical engineering from the University of Florida in 2022. Currently, like was mentioned before, I'm still here at University of Florida, and I'm pursuing my PhD in engineering education. Fun fact about myself is that I was a member of the $1 Million Marching Band at the University of Alabama. I'm a percussionist. And if you guys are old enough to remember, Larry Culpepper, the Dr. Pepper guy from a popular college football commercial campaign by Dr. Pepper. That's me in the middle there with some of the other percussionists from my section. We got to take a picture with him. I think that was at the Dallas Rose Bowl or semifinal game, something like that. But 2015, the year I was in the band, was the year that Alabama went to the national championship and beat Clemson. So roll tide and go Gators. I'm also a dad, so I have two sons, a 2-year-old and a 10-month-old. He turns 10 months tomorrow. And in my spare time, I like to tinker with my cars. And I'm also a documentary person, so I really enjoy documentaries. So we'll talk a little bit about some of the work that I've done as an engineer. I've worked for about 4 different entities as an intern, starting when I was at University of Alabama and continuing while I've been a graduate student. So that was something I found out after I graduated, is that you could still intern as a graduate student. A lot of people don't think about interns as graduate students, but you can keep going. My first experience came from Brassfield and Gorey. They're a popular Birmingham-based general contractor, and I worked 4 semesters with them, rotating as part of the co-op program in project management. And I was introduced to construction here. I also had my introduction into quality control and quality assurance with my time while I was there. The engineers that work here are primarily trained in civil engineering. So although I'm a mechanical engineer, I was around a lot of civil engineers and got to be able to gain some insight into how civil engineers operate. Also, being a licensed professional engineer is a big deal in the civil engineering world, big time. So getting to interact with some of the people that have gone through the process of getting their official licensing to practice engineering as a civil engineer was also cool. Next, I gained experience in manufacturing and quality control further at BMW plant Spartanburg in South Carolina. That's where they make the X Series vehicles. Those are all the SUVs. I did get to go on the driving course there, and as a passenger at least, in one of the sports cars they have out there. So that was a fun experience. But you can see a picture of the Zentrum is what they call that. That's where guests can come visit, right there on the top right. And then as a graduate student, I got to intern with the Southwest Research Institute. They're not one of our national laboratories, but they do federal contracting work. So they're not a government entity, but they contract work with the government. Here, I got a little bit of experience with electrical engineers and engineers with graduate degrees doing research. It was interesting, but it was also a little bit of an asterisk by this experience because it happened summer 2020, which was the height of COVID. So I didn't get to have the same experience that everyone would have liked for me to have, but it was valuable. So next, how am I here with you guys? I am now even currently, an intern with the Air Force Research Lab um, as part of their Air Force Research Lab Scholar Program. So the two directorates that I've had the chance to work with were one, the Sensors Directorate, and two, the Air Force Office of Scientific Research. AFRL has 10 technology directorates, and they lead discovery and development and delivery of warfighting technologies for our airspace and cyber forces. We're pushing the boundaries and creating a new tomorrow through unparalleled research. So, with the Sensors Directorate, they focus on affordable sensor and countermeasure technology for reconnaissance, surveillance, precision engagement, and electronic warfare systems. The goal is to provide robust sensors and adaptive countermeasures that guarantee complete freedom of air, space, and cyber operations for our forces and deny these capabilities to our adversaries. Within the Sensors Directorate, there are, I want to say that's 8 divisions. They're listed here. You can read them at your convenience. I'll save you the trouble here. But the main part of my work that I got to do here was autonomous satellite control related research, if you will. So keeping satellites from crashing into each other and from spinning so fast they come apart, etc., and the autonomous vehicles aspect of that. With the Air Force Office of Scientific Research, there are 4 divisions, all listed here. The AFOSR, on the other hand, plans, coordinates, and executes the Air Force Research Laboratory's basic research program in response to technical guidance from the rest of the AFRL and requirements of the Air Force. They foster, support, and conduct research within the Air Force, university, and industry laboratories, and we ensure a transition of the research results to support the U.S. Air Force needs. So with them, I've worked more in the mentoring and education aspect, outreach aspect, and I'll talk a little bit more about that on the next slide. So work I do now, I partner with the AFOSR, and I work as a technical lead and direct supervisor for interns that partner with us as a part of the Career Technical Education Program in Washington, D.C. Here, I've listed 4 of the big projects that my interns have gotten to work on and that I've gotten to work on them with. One of the big ones is the Engineering Design Challenge Database. That's actually available online now. So if you pretty much Google AFOSR STEM Engineering Design Challenge Database, you should be able to find that, and that's a resource available to everyone. With those students, we designed a template that takes a very holistic approach to engineering design challenges. So you'll see things featured here that you won't see featured in a lot of other engineering design challenge databases, at least to my knowledge. These will include like a relevant person from history, connected videos, connected like historical events that are related to these engineering concepts, etc. And then we also have careers that are directly related to the concepts on display during these challenges. Another one of the projects that students have been able to work on is the Smithsonian Learning Lab collection. So that was a partnership between the AFRL and the National Museum of African American History and Culture. Pretty cool thing. We got to highlight the African American engineers within the AFRL. So you get a little bit of their story, some words of wisdom, and a little bit about what they do. I encourage you to visit that resource if you have time. It's pretty awesome. I've looked through there. Then there's another organization called the Organization for Gender Equity in STEM that was started at one of the high schools in Washington, D.C., where our students are centered. Pretty great undertaking. One of our students was essentially the founder of that organization at her school. And then there's always this open-ended new suggestions or undertakings where you can do different research opportunities. If you want help founding some kind of organization and that's your idea, obviously we'll help you with that. And then new resource types for educational resources. A lot of the AFOSR's materials that are turned over and come out that are public facing are centered around STEM education, increasing scientific literacy, and really there to help educators or curious people at home. So far, I've had the opportunity to work with students from 6 high schools. We're always looking to expand that and also expand down into middle schools. So I'm pretty proud of that and excited about that. So I enjoy working with high school students. And we oftentimes talk to them about different opportunities. I want you guys to take those into account as well. Although I'm an AFRL scholar, like I mentioned earlier, and I'm a PhD student, they also have opportunities for everyone in secondary and post-secondary education. So as a high school student, you can get started. I wish I had known about this program when I was in high school. It's pretty awesome. You get the opportunity to work with professional engineers, people in the Air Force, people in the Space Force, and there's a plethora of topics available for you to research or participate and work on. So that's pretty awesome. If you have the opportunity to do any bridge programs or summer research programs while you're in high school, I also encourage you all to do that. A lot of companies end up hosting research programs or anything like that. If you think already you want to go to grad school, then summer research is a great thing to start while you're in high school. I encourage you all to do USA Jobs. Go to USA Jobs and visit the pathways or search pathways, and you'll see a plethora of opportunities related to all kind of different fields in STEM, especially engineering. Another thing that is possible for you guys to explore for funding your undergraduate education is the Cyber Corps Scholarship for Service. They offer 3 years maximum of funding in return for 3 years of service. So for every year that they fund your education, and that lasts from all the way from bachelor's programs through PhD programs. So I've actually received 3 years of funding from this program myself. You owe essentially the federal government, state government, local government, or some government entity associated with the United States 3 years of your service. It's based on ROTC programs, which I also have listed there, but I encourage you all to check that out if you're interested in cybersecurity. That's the main thing there. If you're interested in any kind of cybersecurity and dedicated to that, then that's a great program to sign up for. If you're interested in joining the armed forces, ROTC programs are pretty awesome. I did junior ROTC as a kid in high school, but did not do that in college. That just wasn't my path, but I have a lot of my friends that chose to go this route, and they've enjoyed their career so far. And then different various scholarships and fellowships. If you have, $500 here, $1,000 there, they add up. So when you see those small scholarships or fellowships, I encourage you all to apply for those. So now I want to go through our mentoring activity. So if you have your pen or paper, or if you have some note open on your device, then I encourage you to get that ready. And I just want to talk to you all about the useful types of mentors to have in your life. This is based on an activity that we just completed in one of my classes, as my advisor is pretty much an expert in mentoring. That's what she has studied. And it's okay to use the same person more than once, but also don't be afraid to leave a space blank for each of these sections. So we'll start with role models. With a role model, this is somebody you can look up to in a sense, and they exemplify a life that can be professional or personal that you aspire to live like. This is somebody like, for me, my boss is the first person that I've worked for and been like, I actually really enjoy what you do. I see the stuff that you have allowed me to gain insight on your daily task and how your work goes, and I aspire to be something like that. So it's been a very good opportunity for me to get to work with her. Another reason you should do internships. I mean, like I said, I've done like 4, and this is the first time where I've been like, I really want to do what this person does. But on a personal level, this can also be somebody who you aspire to have peace like, which is important. Your role model will oftentimes introduce you to other people who you begin to see as a role model. That's been the case for me. So I encourage you, if you have one, then continue to cherish their presence in your life. If you don't, then it's okay, but be on the lookout for somebody like that. Then the next category I have is a master of the craft. So this is somebody who you know is an expert in the field that you may want to go into or that you're just interested in at the time. This is somebody that can offer you technical and professional expertise, and they can help you reach goals. Sometimes it's short term. You may go to, a bridge program that lasts for a week, or some kind of programming that might last for a month, and meet somebody there that's just, exuding that they are an expert in whatever field they're in. And that's somebody you can have oftentimes short term, but sometimes we're lucky enough to meet somebody long term in our life like that. Your advisor, like I mentioned before, I have an advisor formally through the school. Thankfully, she's a great advisor as well, outside of just what the school responsibilities are. But this is somebody that really helps guide you on your path to success. They're not necessarily going to tell you what to do as much as they're going to give you suggestions. They're going to give you warnings and a lot of anecdotes about things that have happened in their life that you can use to inform your decisions. Now, one of the ones that I think is really important is a sponsor. A sponsor is somebody that advocates for you in spaces you may not have access to. So when you're not in the room and they still are team you. That's very important, and they can help broker a lot of connections for you. In my life, I know that I have sponsors. My current boss is a very good sponsor for me, like I've mentioned before. So I'm really thankful for her, and she fills both of those roles. But I have more than one sponsor, which is great. And I encourage you all to not think that just having one person in any of these categories is where you have to stop. It can be enough, but it's not where you have to stop. So on the flip side, on a more personal level, emotional level, things like that, an anchor is somebody that's very important. For me, it's my mom. Like, it doesn't have to always be somebody in a professional space or that you met um, through education, through work, anything like that. My mom's my anchor. This is somebody that acts as a safe space for you. You can talk to them about how you're feeling. They give you that emotional support, and it's important to have that person. I encourage you all, if you're looking for that person and you find that, to cherish their presence in your life as well. Now, anchor is very different from an accountability partner. An accountability partner you have a high level of trust with, that exists between y'all, but they're not afraid to give you a wake up call. This is somebody you can say, "Hey, I'm behind." And they're not just going to tell you, "Hey, go get it done," but they're going to tell you, "Hey, go get it done. What do we need to do to make sure you get it done on time," whatever it may be. So an accountability partner is very important. This can oftentimes bleed into a peer. Sometimes it can be your advisor. So don't think that these are all mutually exclusive. You can have somebody that fills all of these spaces in your life. But an accountability partner is important, especially when you're under deadlines or you're experiencing, more stressful, high intensity times in life. Now, a peer mentor is nice. Think about this kind of like how your best friend is in high school. If you're taking classes together, you're on the team together, you're interested in the same school, that kind of thing. These are people that are at a similar stage or slightly ahead of you on a path towards a common goal. They usually share some type of trait, whether it's age, status with you or experience with you. Like I named earlier, your best friend in high school could really be a peer mentor for you if y'all have similar goals. Now, the last version I have is a coach, or the last mentoring type I have is coaches. Coaches offer you instruction, encouragement, and motivation. Very structured, but kind of counterintuitively. They listen to you a lot, not unlike your coach in a game, but they listen to you a lot and understand what's necessary for you and your game plan. So these people are important in your life. If you have questions about this later, there'll be time at the end for questions. I encourage you to write down whatever it is and put that in. So now I want to go over a couple basics. I found this video on YouTube that covers the large divisions of engineering, large fields of engineering. I want to show you guys that, and then we'll talk about the engineering design process a little bit. So let me get that started for you all. There we go. We're going to fast forward.
You to storm a castle from it. Now, the first of the modern field of engineering to emerge after military engineering was civil engineering. This branch had its official start around the 18th century. Like the name implies, civil engineering was used for civilian purposes rather than military ones. It focuses on building structures of all kinds, along with highways, sanitation systems, and even entire cities. Under this branch of engineering, we might want to study the blob to figure out what properties it has that can be used to solve problems of daily civilian life. Like maybe the blob's goo is better insulating material than what's currently in your house. Or maybe it turns out to be really elastic or waterproof, or have some the property that could make it useful in infrastructure, or urban planning. The 19th century led to an increasing focus on the machinery industry, which gave rise to the branch of mechanical engineering, which I must say, as a mechanical engineer myself, is a fine discipline. This branch focuses on machinery and mechanical systems from robots to engines. Thomas Savery and Thomas Newcomen, two English inventors who are credited with creating the steam engine in the early 1700s, were both mechanical engineers. And so was James Watt, the Scottish scientist who made their design was led by mechanical engineers like them. Then electrical engineering was a natural progression once we were able to generate electricity and create electronics. Dating back to the 19th century, electrical engineering deals with devices and systems that can range anywhere from microchips and cell phones to the giant power station generators that help supply energy to big cities. Electrical and mechanical engineering often come together to create some pretty fantastic inventions. If you want a robot that can move about like we do, You're going to need a mechanical engineer to set up the skeleton of the machine. Then to give it a heart of electricity, you'll need an electrical engineer to provide power to the robot with electronics. And if you want it to act like us too, you'll need someone skilled in computer science, chemical engineering. These engineers have quite a wide focus, not only designing and operating chemical plants that do things like refine oil and distill alcohol, they also deal with food, medicine in the environment, and much more. They're involved not only with the preservatives and artificial flavors found in the pizza pocket you ate last night, but also with the medicine you took the next day to help your upset stomach. Together, civil, mechanical, electrical, and chemical engineering are often seen as the four main branches of engineering in the modern world. But there are many more fields that specialize even further. We have aerospace engineers building machines that fly in the air and space, nuclear engineers harnessing energy released from nuclear reactions, and biomedical engineers creating medical equipment and devices to solve clinical problems. The list goes on, and one branch that supports all of them is industrial engineering. Engineers in this field design and optimize the facilities, equipment, and systems that many other engineers use to create their products. Think of them as the support class of the engineering world. They provide the all-important groundwork for many of our engineering advances.
All right. So that's what I wanted you guys to hear from that video. It's a pretty good overview of some of what are main branches or main considerations when it comes to engineering. Now, one thing that is going to be true for each of these types of engineers and any type of engineers that we all use what's called the engineering design process. This is a pretty good little graphic that I took from teachengineering.org. But it goes through, I want to say, the 7 steps that most people would consider the engineering design process. You'll see more or less steps depending on who you ask. But you usually start out with a problem. So you ask, what is the problem? What are the constraints? Then you research that problem. You look further into the constraints, further into the existing technology, things like that can help you solve this problem. Then you're going to imagine solutions. That's brainstorming. Then you plan out what solution that you want to implement, create a prototype, whether that's a device, a process, etc. But your prototype on how this solution is going to work. You test it and you evaluate the prototype, see how it needs room for improvement, what works, what doesn't work. And then that last step is improve and redesign. So after that, you're back at asking questions about what was wrong with the or why is your problem not solved in the first place. So pretty cool engineering design process. All engineers use this, and like she alluded, we can work together in teams. Sometimes it's with engineers from your same discipline, or like she said, engineers from different disciplines that come together and pool their technical expert.
Need some.
All right. So here is one of the demo videos, or really a basic overview video of sustainable energy storage. One of my first passions that I discovered in undergrad while I took this honors sustainability course was sustainability and energy storage being part of the problem. So a lot of energy can be generated through, say, solar, wind, hydrothermal, et cetera, and generating power. But batteries aren't necessarily the best way to store them all the time. And what do we do when it's nighttime and you want to use your solar energy? Or what do we do when the wind's not blowing and you want to use that wind energy that you generated, but that didn't get used up while it was being produced? This is a video from the NREL, which is a pretty good organization when you're looking into anything energy related. I encourage you to look them up. But without further ado,
Energy storage and the grid are like you and your refrigerator. You fill your fridge with food and you eat it when you need an energy boost. When supply gets low, you restock the fridge so you're prepared for the next time you're hungry. Similarly, an energy storage system kicks on when the grid needs an energy boost. When the energy reserve is running low, we recharge it with the excess generation from renewable sources, like the extra solar energy generated on a sunny spring day when air conditioners are turned off and demand for electricity is low. The power grid uses the stored energy when there's high demand, like a hot summer day when everyone is running their air conditioning. Energy storage isn't running constantly, but it's a safe, reliable backup to ensure the grid has the energy it needs to keep everyone's lights on no matter the conditions. There are many different types of energy storage. Each one converts electricity into a stored form of energy and then converts it back into electricity when the grid needs it. Some energy gets lost along the way, just like some food will eventually go bad in your fridge, but most of the energy makes it back to electricity. Pumped hydropower stores electricity in the form of kinetic energy and is the largest existing source of electric storage in the United States. Excess energy is used to pump water uphill to a storage reservoir. The water is released downhill to convert the kinetic energy back into electricity when the grid needs it. Lithium-ion batteries, like the ones in electric vehicles, store electricity as electrochemical energy and can discharge power to the grid during peak demand. These are just two types of energy storage.
Uh-oh.
There are lots of other energy storage technologies in the works, but for now, batteries will likely make up most of the near-term deployments.
Getting some.
As energy storage technologies continue to get cheaper, more are being added to the grid. Energy storage can help the grid respond to unexpected changes, like outages from wildfires or storms. And energy storage solves the challenge of how to keep a renewable-based grid running when wind or solar aren't available. So, like your fridge that keeps food fresh, energy storage helps save clean energy to power a flexible, resilient, carbon-free grid. Learn more about energy storage at nrel.gov/storage.
All right. So that video I thought explained some of the very good basics about sustainable energy storage. They mentioned pumped storage, hydropower, and electrochemical storage. And they mentioned that these other ones exist, but I wanted to talk to you a little bit more about those. So the chemical reaction that happens when energy or electricity is fed into a battery is what they're talking about with electrochemical storage. But with thermal energy storage, it's a family of technologies in which a fluid is heated up and it's used to store that heat. And then that heat is used to boil water that in turn generates the electricity that you need later on. Expanded energy can make, with a flywheel storage, there's a flywheel, and when energy is released into the flywheel, it turns an electrical generator, and through electromagnetism, the wheel is slowed down and produces electricity that you need. For compressed air storage, there's usually a large tank, and the pressurized air is built up while the energy is high in excess, and then it's released and used to drive a turbine to create energy when you need it and it's not being produced. With solar fuels, solar power can be used to create fuels that can be combusted and provide energy later on, that are broken later. And then and virtual storage is really a change in behavior sometimes in how we use the devices we already have. For example, we can heat or cool a building before we need the highest demand, doesn't need, or store that thermal energy so it doesn't need to use it later on in the day. So sustainability is big to me. It's big to others. Are creating solutions to help solve that problem. That's I would say that's going to wrap it up for me. Like I said, my name is Jabari. If you have questions, I would love to answer those in the chat. This QR code you can scan and you can connect with me on Instagram, LinkedIn. I want to say this is X now. Sorry, that might be a little outdated. Slides Go is where I got the presentation template from. And here are some resources for you all as you navigate through high school and on into undergrad or your next endeavor. We can't hear you, Miss Smith. I think you're still on mute.
I was still on mute. Sorry about that.
No worries.
So there are no questions in the chat, but people can feel free to have any questions in the chat. But I add later. But I have a few questions for you.
All right.
The first question I have is, this is my little comments. Unfortunately, you weren't in, the Marching 100 where you got a different band experience, but
Correct.
you did have this thing where you got to explore interests outside of your engineering by being in the band during college. And so my question is, engineering is hard in itself. So how did you manage and balance being in the band and still staying abreast of your courses? Like, did you have help? Were you on a strict schedule? Because I could imagine being in any band, no matter what school, you being very demanding, and also people telling you like you can't pursue your engineering degree and be in the band, like you have to choose, right? And so I'm curious how that journey was for you.
Oh, that's a great question, and I appreciate it. So like I said, I was in the band in 2015. The fall season is the football season, and that's when it's most intense. Honestly, it was also intense for me because that was when I crossed fraternity. I'm a member of Alpha Phi Alpha Fraternity Incorporated. So it was an extra intense semester for me with the extra learning that I was doing. I would say that having accountability partners, like I spoke about in the mentoring slides, was very important. There was another member of the band that was in one of my classes, and she used to help me with, if I missed something in the notes or if I just needed help. We would sit next to each other and make sure that we were, on task in class. Also, going to office hours, which you'll learn more about in undergrad. Those are pretty much times that your professor has set aside for you to come speak to them one-on-one. And they're usually pretty understanding, in my experience, when you have some outside activity going on. For example, the band, we had to travel, obviously. So they were really gracious with me when it came to, assignments and due dates, which I enjoyed. But balancing was definitely a concern. That's why I waited until 2015 to join the band. I wanted to get my feet under me academically. There's pros and cons to that. I think I should have done it earlier, so it was just integrated into part of my life. But definitely those accountability partners, definitely going to office hours with the professors and using some type of organization system. I like planners. I like calendars. And, if you have a whiteboard or you want to use sticky notes, whatever your system is, keep track of, to-do items that you have and set goals for yourself throughout the day to, hey, I'm going to get to this point in this assignment, and then I'm done with it for the day, work ahead, those kind of skills that you pick up when you're balancing a lot on your plate. So I hope that answers your question well enough, but that's a great question. So
you made a good point, which is not a question I had, but a question I thought about. The importance of communicating with your professors and going to office hours. How important is that for successful matriculation through college, especially as a STEM major?
It is very important, I would say. And I honestly would say start in high school. I started it in high school. I would talk to professors or, teachers in this case after class. I had a special exception made my senior year of high school to take an extra math class. I wanted to take AP Stats and AP Calc. And I made that decision a little later in the class or in the semester, but I hadn't missed enough for it to really damage anything. So being able to go speak to that teacher and her say, yeah, it's fine if you join now, there's no issue, and having my schedule changed. Like, I saw the influence that going and speaking to a teacher could have in high school. So being encouraged to do it in college almost came naturally. I had a very difficult time in my first physics class. I did not have the opportunity to take physics in high school. So my first physics class was in college. It was tough, but I went and spoke to that professor. I tried to get help. Once again, I had a peer mentor in this case. I didn't have an accountability partner as much as he was a peer mentor, but I found me a buddy and we worked together all the time on physics things. He was ahead. He had taken physics before, and we were, had a common goal and trying to reach it together. And he was very helpful and instrumental in my completion of that course. So going to office hours and getting an understanding of what the professor wants in graduate school, that's paid off for me as well. I was struggling in a class and I went to the professor and they told me that they really teach from a perspective of, we want you to progress. So if you're making progress, that's what's important to me. Not necessarily that you are getting all A's, but that if you started out at a D, you're now at a B. That's important. That's A+ work in their head. So getting that idea, asking your questions, showing up shows that you're willing and you're working. And those are two things that are going to pay off and go a long way for you as you try to matriculate through your educational journey.
That's good. So you mentioned internships, right? And with
Yes.
internships, we often talk about, what we learn, the technical skills that we learn. But my question to you is, throughout your various internships, can you talk a little bit about the soft skills you may have learned as a result of those
Yes.
internships, as well as the important relationships, especially with people that were your peers, in the internships?
So those professional skills are very important and oftentimes go underemphasized. But I think that for the nature of a lot of the internships that I had, they were almost put in the forefront. With construction, particularly, that field has a lot of workers who don't necessarily have a formal degree in education, but they're very skilled in what they do and very knowledgeable. I've met somebody that was doing his job for longer than I've been alive and almost longer than my dad had been alive. So who am I to come out here with this, textbook knowledge and try to tell him how to do his job? But an attitude will have a very large impact on how you're received and how well you'll move through the job place. For me, I was not afraid to say I don't know. And that's that is very important to get over early. I've literally had my supervisor go out, point to an object like that's up in the construction site and say, "What's that?" And it seems like a little embarrassing to go, I don't know what that thing is. It looks like it's a support or it looks like it's this. But they respect that. And now you've shown that if you're an athlete, you're coachable. If you're an academic, you're teachable. And if you're a worker, then you're trainable. So being able to come in with that kind of attitude and show that has been very important. And learning how to speak professionally, everybody doesn't have the same, dialogue that you have at home. So learning how to use certain words, use certain tone is going to be important as well. Email communication, professional networking, these are all professional skills that have gone a long way for me since starting interning. I still have a good rapport with a few of the people that I worked with at Brasswood and Gorey, and that was all the way in 2014 when I started with them, so almost 10 years ago. But as I've moved forward, those things have proved to be pretty important. Sorry, mosquito. But yeah, I hope that
Yeah.
Great question.
So as an engineer, that bachelor's is hard to get, right? But you decided to go
Yes.
and get a graduate degree in engineering. What made you decide that you wanted to have an additional, a graduate degree in engineering?
Well, I would say that came from one of my talks with what I would consider a master of the craft. So I can't even tell you specifically who this was, but I remember the interaction being somewhat short and them being, like I said, a master of their craft. And what they kind of summed up for me was, if you have a bachelor's and you go into the workforce, then you're going to do the work that you're asked to do. And, if that's where you want to be, that's fine. But that is not necessarily the ceiling for your job, but by your degree and by the requirements as things go up and for eligibility for new roles, that'll be the ceiling. With you, when you get your master's, you'll have some ideas, and you'll help, oversee and supervise people that are doing what they've been asked to do. And then when you have your PhD, they said, that's who's coming up with the ideas. That's who's really having the foundation. And what is it that the plan is? What is it we're doing? I thought that I wanted to do research and development from a young age. So I knew that going all the way to the PhD would put me in a position to be in any place that I want to be for the most part. And I would liken it to a driver's license. If you get your bachelor's, you have your Class D driver's license, you can drive a car. You get your master's, you got your Class DM, you can drive a car or a motorcycle. It doesn't make you a good driver. It doesn't make you a bad driver, but you're licensed to do so. So you have the ability to move to that place and do it, within the confines of the law and easily. You get your PhD, now you have your DMV, you got your CDL
Mhm.
to drive, and having that freedom was one of the motivating factors. The other motivating factor was that that's not something that I've seen a lot. I haven't met them for.
Okay. So this is my last question, and then I'm going to ask you to share your words of wisdoms to the next generation. So you've had these engineering degrees, right? And now you're doing engineering education. So what made you have that shift from, you know, doing the work to a focus on how do you train and encourage future engineers?
That's a wonderful question. I think that for me, like I've alluded to with my internship experience and a little bit of the physics story, etc. Being prepared for where I was something that I gave a lot of thought to, how I was prepared to go where I was going. And I felt like for my PhD, I didn't begin in engineering education. I actually began in mechanical engineering. I enjoyed my project. I found the passion in it. I was looking into autonomous public transportation as it relates to accessibility. So accessible autonomous public transportation. There are a lot of implications for accessibility when it comes to autonomous vehicles. And I thought it was great research. I enjoyed it, but I also have always had this passion for engineering education and outreach. Like I mentioned, or like was in my bio, I had tutored students in calculus, AP calculus, when I was a freshman going into my sophomore year in college. I was a tutor with chess, for middle school students during my junior and senior year. There's a large mentoring aspect to my fraternity and talking to a lot of the guys that come in and are younger. And then when I got to the University of Florida, I was part of a project that was looking into the experience of Black undergraduate and engineering students here at the university. So there was always this lining and this theme of education and of outreach and kind of pay it forwardness that followed me through my matriculation to grad school. And through meeting the professor that I was working with for the project that I mentioned with looking into the engineering experience for Black undergraduates, she's my advisor now. I had the opportunity to work with her. I love the work, and I wanted my pursuit of my PhD to be something that encapsulated what I am already passionate about, not something that I had to build a passion about. And I've enjoyed the coursework now, which is a new phenomenon for me in a way. There have been courses I liked, but there's also a lot of courses that you just get through. But my courses now, I enjoy the content. I enjoy what I'm researching. I enjoy what I'm learning about. I enjoy the discussions. So switching that PhD to be something that I'm actually passionate about, I can go to bed thinking about, I can wake up thinking about, and it is not a drain on me, but something that feeds my motivation and feeds that fire, was really my motivation to switch into engineering education rather than the technical work. There's people that love robotics, and that's what they want to do. I encourage you to go all the way with robotics, go as far as you can, be the person that creates the next thing, and that be what you do your dissertation on. But for me, I've always loved outreach. I've always loved education. Um, so I chose to go ahead and switch over to something that has just been a passion of mine that I never gave formal training and education to.
That's good. So the last words are yours. So think of whatever you would tell young Jabari or somebody that, is that thing that is thinking about engineering, that is thinking about how they, will shape their path to becoming an engineer. What are words of wisdom that you would give that person? Young Jabari or maybe young Jaleesa,
Got you. I would definitely encourage them to not be afraid of not knowing, and always apply. That's one of the things I'll say. Check your email, please, and apply. Even if you don't think you're qualified, even if you don't think it's going to be the most fun, you're not going to know going in exactly what you want to do all the time. You're not going to know what to expect all the time. But um, having these experiences has been very powerful to me. Like I said, I've worked in a few different industries, had a few different chances and experience. And there's a lot of just figuring out I didn't like something. I would go do an internship, make money, make my connections, gain the experience. I'd leave and say, that's not what I want to do at all. I know that I don't want to do manufacturing. I know that. But I learned that by going and working in manufacturing. And that is still a positive experience. In the course of doing that, like I said, I made money. That was important to me. I made a few dollars. I made some connections and met people. I've met, a lifelong friend while I was in South Carolina. Real, that's one of my buddies now. So I made the connection. And I learned that even if it's not what I want to do, I've narrowed things down. I've eliminated something else. So I know I don't want to go into manufacturing. What's next? Take advantage of internships, take advantage of college, enter with the mindset that you're attending a university. It's called a university. You're supposed to gain a universal education there. It's not just, finish your coursework and get out. You have the opportunity to grow socially, to grow mentally, to grow emotionally. And those are things that you can take advantage of while you're an undergrad that you can't take the same advantage of when you're not there. So, it's like having the bumpers up at the bowling alley. The bumpers are up when you're an undergrad for the most part. You can try an internship and not like it. You can mess up at work, and they don't expect you to know everything. You're still a student. But, once your well-being is on the line, it becomes a little more intense. Those bumpers go down, and you don't want to roll a gutter ball. You want to be already good at, rolling strikes. So those are my words of wisdom as you mature and as you move on to the next steps in your life.
thank you so much. That was so great. And I really appreciate you taking time for this. But I'm going to say this one last thing. What I really appreciate is that mentoring chart, because I think that, let me not say I think, we usually see like friends, sponsor, mentor. And I was like, oh, okay. Like it's a whole bunch of different roles that people play. And I
Yes.
think that knowing, expanding the number of roles allows us to really know like who a person is so we can manage our expectations and gain the most out of that
Right.
relationship. Because I think sometimes people are like, that was supposed to be my mentor. And they weren't. They were like one of those other roles. So thank you so much for sharing that. And we hope that
No problem.
everyone that was in attendance live or that watched this later on YouTube, that you really, really get. I learned a lot about how you navigate your career as an engineer from high school to college, and knowing that you have to be open to new things. You have to be okay with not knowing. You have to invest in your relationships, not just your coursework or technical expertise. And you have to be open to try new things, and be able to change directions, right? And most importantly, explore your other interests too, right? If you want to play in the band, if you like all of those things, be well rounded. All right. Well, thank you so much, Jabari. We appreciate you giving some of your time for this month's virtual Teen Science Cafe.
No
And good
problem. Thank you
night.
so much for having me.
And we'll see you at everyone at the next cafe. I'm going to put a link in the chat for an evaluation. So get an opportunity to take our survey. All right. And I'm going to end this stream.